Now, next article is electric field due to non-conducting or dielectric uniformly charged sphere, or sometimes it is known as uniformly charged solid sphere. This is original in 3D, three-dimensional, uniformly charged solid sphere. Means considered as a nucleus or cricket ball. Material of cricket ball is act as a positive charge. Then Q is the total charge on the sphere. R is the radius of sphere. V is the volume of sphere. 3 point. P is the outside point. This point P. S is the surface point. And M is the inside point. At 3 point we have to calculate electric field intensity. Important is what is rho. Rho is volume charge density because it is a uniformly charged sphere. Charge per unit volume. Now same procedure for calculating the electric field at any point. First consider the imaginary Gaussian surface. This is imaginary Gaussian surface sphere whose radius is smaller. Consider a small element ds and calculate flux passing through ds and integrate. Therefore, we direct consider as according to Gauss's law by Gauss's law. Integration of E ds. We have to consider electric field intensity at point P is E ds equal to Q enclosed by epsilon 0. Now E and normal vector to Gaussian surface is parallel. Therefore, E integration of ds dot product cos 0. Q enclosed is nothing but charge on original solid sphere, capital Q. Therefore, charge enclosed is capital Q by epsilon naught. Integration of ds is nothing but this area 4 pi r square. Therefore, we get E 4 pi r square Q enclosed means capital Q by epsilon 0. Therefore, electric intensity is 1 by 4 pi epsilon 0 Q by r square. Therefore, electric field intensity at outside point R is greater than radius is same as a electric field due to conducting sphere. In conducting sphere also we have to consider this small whole charge is concentrated at the center. In this case also for only outside point consider total charge is concentrated at center and r is the distance. Then equation is 1 by 4 pi epsilon 0 Q by r square. If we put Q as rho 4 by 3 pi r cube, then we get rho r cube by 3 epsilon 0 r square. Now for same non-conducting sphere, uniformly charged sphere or solid sphere, we have to calculate what is electric field intensity at the distance x from the center. It means at inside point. Now by Gauss's law, same equation, integration of E dot ds equal to Q enclosed by epsilon naught. Now again electric field intensity at point is considered as E, small area is considered as ds, normal to small area is parallel. Therefore, E dot ds cos 0 is 1. Electric intensity at each point on this Gaussian surface is fixed. Therefore, E is out of the integration. Therefore, E is out of the integration. E integration of ds. Now, Q enclosed. What charge enclosed by Gaussian sphere? For outside point Gaussian, for this Gaussian surface, charge enclosed by Gaussian surface is total charge. But what charge enclosed by this Gaussian sphere? Now remember that this charge is uniform distribution of charge. Therefore, for total charge Q, density is rho and then sphere is 4 by 3 pi r cube, original sphere. Now consider small q is charge enclosed by this Gaussian sphere is Q. Then rho is same because uniformly charged sphere. Now volume is 4 by 3 pi. Now volume is 4 by 3 pi x cube. For total charge Q, rho 4 by 3 pi r cube, and for this Gaussian sphere Q, rho 4 by 3 pi x cube. Then Q by Q is equal to, we get x cube by r cube. It means Q equal to capital Q x cube by r cube. This gives charge enclosed by Gaussian sphere. Now charge enclosed is Q x cube by r cube. Integration of ds is area of this Gaussian sphere, 4 pi r square. Therefore E 4 pi x square, and Q x cube by r cube. Now we get E equal to x square and x cube cancel. Therefore 1 Q by epsilon, this epsilon 0. Then we get 1 by 4 pi epsilon naught Q x by r cube. This x square and this x cube remaining is x. If we put capital Q is equal to rho 4 by 3 pi r cube, rho x by 3 epsilon naught. It means E inside is directly proportional to x up to the surface at the center of solid sphere. X equal to 0, therefore electric field is 0 at the center, but not inside 0. It increases from center to surface, directly proportional. It increases from center to circle with directly proportional to x up to the surface, and on the surface it is a maximum. Now what is the electric field intensity on the surface of this uniformly charged solid sphere? Again consider on the surface Gaussian sphere and apply the Gauss law. Apply the Gauss's law. Integration of E vector dot ds Q enclosed by epsilon naught. Electric field on the surface is E and area vector is normal. Then E ds cos 0. Cos 0 is 1. Therefore E integration of ds. Q enclosed is nothing but total charge Q by epsilon. Now integration of ds is the area of this solid sphere. Area of solid sphere is nothing but 4 pi r square. Q enclosed is total charge Q by epsilon naught. Therefore E on surface is 1 by 4 pi epsilon naught Q by r square. If we put Q equal to rho 4 by 3 pi r cube, ES equal to rho r by 3 epsilon 0. And this is the maximum value of electric field on surface. Take the screenshot of this. On the surface, put x equal to r in this equation. We get this rho r by 3 epsilon 0. Or we put small r equal to capital in this equation. We get rho r by 3 epsilon 0. Right? Now graph electric field intensity at the center of this solid sphere is 0 and increases up to the surface directly proportional to r or x. Then outside is inversely proportional to r square. Charges Q, 2Q and 3Q are uniformly distributed in 3 dielectric solid sphere. Uniform है और dielectric 1, 2, 3. Radii r by 2 r and 2r. Magnitude of electric field at point P at a distance r from the center. Now for first figure, point P is outside. For second sphere, point P is on the surface. And for third sphere, point P is inside. Then formula for outside is 1 by 4 pi epsilon 0 q and distance r square from the center. Now charge on the sphere is q and distance from the center is capital R. Then 1 by 4 pi epsilon 0 q, then distance is capital R square. This equation gives electric field intensity at outside point, at this point. Total charge is considered as a center. Point P is on the surface. Therefore, electric intensity for surface is E2 equal to 1 by 4 pi epsilon 0 charge on sphere by R square, radius square. Now 1 by 4 pi epsilon 0 charge on the second sphere is nothing but 2q and radius r. Therefore, charge is 2q and radius is r. Therefore, r square. And for third figure, radius is 2r, but we have to calculate electric field at point P at a distance r from the center. Charge on the sphere is 4q, that is, this point is inside, and electric field for inside point is 1 by 4 pi epsilon 0 q, x is distance from the center by r cube, radius cube. Now 1 by 4 pi epsilon 0 charge on the sphere, charge on the third sphere is 4q. Therefore, instead of q, 4q, and distance from the center of sphere is r, and radius is 2r. Therefore, radius 2r cube. Get 1 by 4 pi epsilon naught 4qr by 2 cube is 8 into r cube. Therefore, we will get 1 by 4 pi epsilon 0 equal to q by 2r square. In first equation, we get 1 by 4 pi epsilon 0 q as a constant by 1 by r square. In second case, 1 by 4 pi epsilon 0 q as a constant 2 by r square. In third, 1 by 4 pi epsilon 0 q is constant by 2r square. Therefore, maximum electric field is on the surface, again E2, then E1, and minimum is inside q by 2r square. Here in denominator q by 2r square. Therefore, E3. E2 is greater than E1 greater than E3. Be the charge density distribution for solid sphere of radius r. Now solid sphere is nothing but non-conducting. Total charge q. Let for point P1 inside the sphere, for inside this solid sphere must be non-conducting, because for conducting inside point electric field intensity 0. Now what is the electric field intensity at a distance r1 from the center of sphere? The magnitude of electric field calculate करना है. Now for calculating the electric field intensity at this point, at point P, at point P1, consider the Gaussian sphere of radius r1 and apply the same equation. Integration of E dot ds equal to q enclosed by epsilon naught. But in this case, charge density is non-uniform, and for non-uniform charge distribution we must solve this problem by using a integration method. Now left hand side above equation is E integration of ds, right hand side q enclosed by epsilon 0. Integration of ds nothing but the surface area of Gaussian surface, 4 pi r1 square, E into 4 pi r1 square, because electric field intensity is calculated at a distance r1 at point P1. Now right hand side is q enclosed by epsilon 0, equation 1. Now This non-uniform charge density means what amount of charge enclosed by Gaussian sphere is changes from center to distance r1 by equation rho r equal to qr by pi r raised to power 4. It changes according to r. When r increases, rho changes. Volume charge density changes. Therefore, for calculating Q enclosed by Gaussian surface, we first consider a differential area 4 pi r square of radius small r, and its thickness is nothing but dr. Area is 4 pi r square and thickness dr represent the volume. For solving this type of problem, we will not consider volume as a 4 by 3 pi r cube, because volume charge density changes according to r by equation qr by pi r raised to 4. Therefore, first consider a differential area 4 pi r square and thickness dr represent the volume. Now, then what amount of charge enclosed by our Gaussian sphere? Let consider charge enclosed is q. Q enclosed is nothing but q is integration of 0 to r1. Charge is product of volume charge density into volume. Volume charge density is q r by pi r raised to power 4. This density, and now volume is 4 pi r square dr. This amount of charge is present up to the radius small r from the center, but for calculating total charge enclosed by Gaussian sphere, integrate above equation from limit 0 to r1 is constant out of the integration, and also r raised to 4 is constant. Therefore, integration of 0 to r1, this r and this r square get r cube into dr. Integration of r cube is r raised to 4 by 4. Put the limit 0 to r1. 4 get cancelled. Therefore, q equal to q by r raised to 4. Put upper limit r1 4 minus 0 lower limit. Therefore, charge enclosed by Gaussian surface is q r1 4 small r1 4 by r raised to power 4. This gives the charge enclosed by Gaussian sphere. Now put equation 2 in equation 1. We get E into 4 pi r1 square. Equation 1 is E into 4 pi r1 square equal to Q enclosed capital Q r1 4 by r raised to power 4. This r1 square and r1 4 remaining r1 square. Therefore, E equal to Q r1 square by 4 pi r raised to power 4. Now, in this equation 1, denominator is epsilon naught. Therefore, put here epsilon naught. We get E equal to Q r1 to the power 4 by 4 pi epsilon 0 r to the power 4. Answer is 3. C. Q r1 square by 4 pi epsilon 0 r raised to power 4.